This video is going to be on phosphorus physiology and also how we measure phosphorus in the ClinPath lab. So phosphorus physiology is very similar to calcium physiology. I'm also going to draw an enterocyte and a blood vessel, and that's because phosphorus is primarily acquired from the diet, and the phosphorus is absorbed by that enterocyte and enters blood. The absorption of phosphorus can be enhanced by vitamin D, but it's not enhanced by PTH. So that's one of the differences between calcium and phosphorus. Once it's within the blood, phosphorus is also found in various fractions. Similar to calcium, it also has a free form, a non-protein bound form, as well as a protein-bound form. But the big difference between phosphorus and calcium is that the protein-bound form of phosphorus is much, much lower than the protein-bound form of calcium. So, while hypoproteinemia, so decreased protein concentration, can cause hypocalcemia, so low calcium concentration, hypoproteinemia does not cause a decreased phosphorus concentration. Now, the way we measure phosphorus in the ClinPath lab is that we measure all of phosphorus. So this appears on the serum chemistry or plasma chemistry reports, and that is a total phosphorus in blood, and specifically it's the inorganic phosphorus, so the phosphorus not attached to organic compounds. Similar to calcium, phosphorus is also deposited in bone, and the bone acts as a reservoir for phosphorus when it's needed. And this bone resorption is enhanced in the presence of vitamin D as well as PTH. But unlike calcium, phosphorus resorption isn't inhibited by calcitonin, so that's another difference between calcium and phosphorus. Similar to calcium, phosphorus is also excreted by the kidney. So I'll draw the kidney here and the ureter, and the kidney is going to be attached to the blood vessel that's the main blood vessel in this picture. So phosphorus is freely filtered by the glomerulus, and whether phosphorus is resorbed back into blood or excreted by the kidney into urine, again, depends on those hormonal influences. Resorption of phosphorus is inhibited by PTH, and it's also inhibited by calcitonin. So increases in both of these hormones can lead to less resorption and therefore more excretion of phosphorus in the urine. So this is different again from calcium. Remember, PTH enhanced calcium resorption by the kidney, but in this case, it's increasing phosphorus excretion by the kidney. So note that PTH both resorbs phosphorus from bone and excretes phosphorus by the kidney. Now, of these two functions, the excretion by the kidney is much, much more powerful. So there's more phosphorus being excreted than being resorbed by bone. So the net effect of PTH is to decrease blood phosphorus, and in doing so by renal excretion of phosphorus. So I'm going to erase the top part of this blood vessel so I can write the net effects of these hormones. Vitamin D acts to increase the blood phosphorus. PTH acts to decrease the blood phosphorus. And calcitonin also acts to decrease the blood phosphorus. So that's a summary of the phosphorus physiology and also what we measure in the ClinPath lab. Again, the hormones are very similar, and also the cells and organs involved are very similar to calcium. So it's important to pick out the differences and also know the overall effects of the hormones on both calcium and phosphorus.